Hello, in this video we are using the z-score formula to solve for the other variables, x, which is the data point, mu, which is the mean of the data set, or sigma, which is the standard deviation of the data set. For our first problem, we're again looking at that 1973 study done by the CDC, which found that 12-year-old boys had a mean height of 151 centimeters with a standard deviation of 8.18 centimeters. This time, I'm going to be given a z-score, and I want to solve for the height, which is the data value on the original normal curve. So in this case, we are undoing the standardization. If a 12-year-old boy in 1973 had a z-score of z equals 1.23 for this distribution, how tall was he? In this case, we are plugging in 1.23 for z. X is our data point for actual height, so that is going to be left as x. Mu, the mean, is 151.1, and the standard deviation is 8.18. I want to solve for this x. To get the x by itself, I need to clear the denominator. Right now, x minus 151.1 is being divided by 8.18. To undo that division, we're going to multiply by 8.18 because multiplication undoes division. Since we multiply on one side of the equation, we have to multiply by 8.18 on the other side of the equation as well. When we do this, we get 8.18 times 1.23 equals 10.0614. Over here, the denominator cancels with the 8.18 where we multiplied, and all we have left is that original numerator, x minus 151.1. Now to solve for x, we are going to add 151.1 to both sides. Right now it's x minus 151.1. To undo subtraction, we add that amount to both sides, and we end up with 161.1614 equals x. If we round this to one decimal place, we have x as 161.2 centimeters. So a 12-year-old boy in 1973 with a z-score of 1.23 would have been 161.2 centimeters tall. In the next problem, we have the lifetime for a handheld video game system. This has a normal distribution with a standard deviation of 2.1 years. Ava had bought a system that lasted 8 years, and it meant that system had a z-score of 1.56. We want to solve for the mean lifetime of this handheld video game system. We are going to use the same standard formula, z equals x minus mu over sigma. This time it is mu that we're solving for. So we have 8 years, which is the data point, standard deviation of 2.1, and a z-score of 1.56. That gives us 1.56 equals 8 minus mu over 2.1. Same idea as last time. I have this mu inside of a fraction, and I want to clear the denominator first. Currently, 8 minus mu is being divided by 2.1. To undo the division, we will multiply that side by 2.1. If we multiply that side by 2.1, we will multiply the other side as well by 2.1. 2.1 times 1.56 gives us 3.276. So now we have 3.276 equals 8 minus mu. Remember, the 2.1 in this denominator cancels with the 2.1 we had here. Now I have 8 minus mu. I want to get rid of this 8. Currently it is a positive 8. I can get rid of it by subtracting 8 on both sides. And that gives me negative 4.724 is equal to negative mu. This subtraction is now a negative mu. We have a negative on both sides, which we want to get rid of. And we can do this by multiplying each side by -1. That gives us 4.724 equals mu. In other words, the mean lifetime for this handheld video game system is 4.724 years. In our last example, we have a large random sample of 70-year-old adults, and we measured how long they slept each night. They had a mean of 7.1 hours per night, and we have the data point that Cheryl, who sleeps 6.2 hours a night, has a z-score of -0.74 on this normal distribution. We want to find the standard deviation for the number of hours slept by 70-year-old adults. Once again, we are looking at z equals x minus mu over sigma, and this time we're solving for sigma. Z is -0.74, and that went along with the data value, 6.2 hours. The mean amount of sleep was 7.1, and now we're solving for sigma, which is in the denominator. Similar to the last two examples, I want to clear the denominator. This time, the variable that I'm solving for is in the denominator, so that is what I'm going to multiply both sides by. When I multiply it on the right side, the sigma in the denominator cancels with the sigma which I multiplied by. On the left side, I'll get -0.74 sigma, and this is equal to 6.2 minus 7.1. Because this is -0.74 times sigma, I can get the sigma by itself if I divide both sides by the -0.74. When I do that, the -0.4 in this numerator cancels with the 1 in the denominator from the division. This tells me my formula for sigma is 6.2 minus 7.1 over -0.74, and we put that into our calculator and get 1.22 hours. From this distribution, the standard deviation is 1.22 hours of sleep for 70-year-old adults.